Let's take a look at our simple RC circuit again and see how it can be used to make a high-pass filter. And just as before, we have another voltage divider expression and if we multiply both the top and bottom of our fraction with JWC, we wind up with the expression here JWCR over 1 plus JWCR. And like before, we now have an expression for our transfer function. So this is our input signal, and this is our output signal. So that means that what's remaining over here that relates the two of them is our transfer function. So the transfer function for this particular circuit is JWCR over 1 plus JWCR. And we said that this was a high-pass filter, but let's go ahead and check to make sure that this is true. And so let's see what happens to our transfer function as our frequency approaches 0. So this value would approach 0, and this value would approach 0. So we would have 0 over 1, which is 0. And then if we took our transfer function and pushed our frequency towards infinity, well, we would have a really large value over a really large value plus 1, which is effectively infinity over infinity, and L'Hopital's rule gives us that this is going to end up being 1. So again, at low frequencies, signals are rejected, and at high frequencies, signals are allowed. And so for this RC circuit, when we measure across the resistor, we get a high-pass filter. And just in the same way with our low-pass filter, this behavior is dictated by a corner frequency, and for both RC types of filters, the corner frequency is 1 over RC. So for both a high-pass and a low-pass filter, they can be made with RC circuits with just a resistor and a capacitor, and depending which component you measure across will give you either a low-pass or a high-pass filter. But for either one of those filters, the corner frequency is dictated by 1 over RC.